Okay, so we're recording. So like your voice would show up on YouTube right now, which is not that scary. There's a lot of stuff on YouTube that never gets watched. Liz, would you like to give a shout out to YouTube Nation?
I would like to give a shout out to YouTube Nation.
Wow, that was epic. People will be playing that back forever. Probably not. Most videos don't get watched because it's just, in case you miss class. So I guess it's good we're doing it because we have a few people gone today, right? So people will go back and watch the video so that they know what's going on. They'll get it figured out. We pick up with example C where we left off yesterday. We're going over properties of exponents today. Get rid of any negative exponents. I multiply the 3 and 4, get 12. What do I do to the exponents? I add them. But problem D is a little bit different because I have some negative exponents. What should I do there? Yeah, so a lot of people like to move them where they're not. So, you want to move that down, that up, and this down. And there's multiple ways of doing it, but this is one that people choose. So looks like that would be a b to the seventh on top then, an a to the eighth, and an a to the fifth on the bottom, and then a b to the third on the bottom. So it looks like here I have a b to the fourth divided by a to the 13th. Some people would do that differently. When I saw this problem when I was your age, I didn't do it like that. I just did subtraction. So what's negative 5 minus 8? So that would be on the denominator since it's negative. And then what's negative 3 minus negative 7? So that's on top. Right? So, the subtraction rule for the exponents works just fine. But I know you guys like to, the fact is, people tend to make mistakes when they do it that way because we're maybe not as gifted with subtraction as we like, right? Like we like addition more than subtraction. We like multiplication more than division. We like integers more than fractions. I get it. I get it. But if you want to subtract, go ahead. Okay, so letter E, this is one that gives people a problem from time to time on the test. And, a lot of people want to do this. So if I have 3 times x squared plus 2y, that comes out to be 3x squared plus 6y. But that's distributing over addition. Do I have any addition here? No. So a lot of people are like, well, I got to take the 3 there and the 3 there. No, there's no addition. This is all multiplication with some powers. So what am I going to do first? Which part of this do you want to deal with first? And deal with that guy. So I have 3 times xy to the fourth. And what do I do to the cube? Or to the 2? Do I cube it or multiply by 3? Cube it to get x to the 12th, y to the... Now, this 3 out here, are these parentheses really necessary? Isn't that really just 3xy to the fourth times 8x to the 12th, y to the ninth? Yeah, so sometimes parentheses are used to group certain things together. In this situation, you can take them off because it's all multiplication. So 24, x to the, and y to the, very good. Okay, how about f? There's about 5 different ways to do this. What would be your first choice for approaching this type of problem? Okay, so you want to flip everything. Do I move the 2? Is the 2 being taken to a negative power? Yes, so it moves. A lot of people, when they do this, they forget to square it still. They're like, well, I use that up. No, you just use the negative up, not the 2. So do you want to square it or do you want to work on the inside? What do you want to do? You want to square it? Okay. So go 4x to the negative 6, y to the 8th, x to the 6th, y to the 6th. Now what? Okay, so if the x to the 6 goes on the bottom with that x to the 6, then I should get a x to the 12th and a y to the 6th. Now you take care of your y's, 4y squared over x to the 12th. And there you have it. Not too bad, huh? Oh no, now he makes us do fractions. Oh, hate fractions. It's like I think of the word hate, like like I don't know, like I hate, you know, I don't know, war, right? Like think of things you hate in life. I hate war. I hate poverty. I hate racism. I hate fractions. Now, see, fractions doesn't really fit into all that, does it? Like maybe loathe. Like I loathe the fractions. I strongly dislike. Poor fractions, they get such a bad rap. If you don't know how to deal with the fractions, make an easier problem. That's what I always do. If I don't like the problem, I just make a different one. And then we got 5a to the, say, fifth. So that's pretty similar to the problem I've written down. I know that this answer is just negative 10a to the eighth. So what did I do to the exponents? I just added them. So it looks like I'll just add those exponents. So I'll have negative 10 a to the, well, I have to add 3/4 and 3/2. How do you do that? Ooh, create common denominators. So 6/4, which makes 9/4. There you go. So people wanted to multiply through by 4 to get rid of this 4. It's totally illegal. That's made up mathematics. Can't do that. Doesn't work like that. Okay. H. Oh no, more fractions. Well, if it's a power to a power, what do? Multiply. Well, that's not too bad. So 6 times 3/2 would give me, so I got 6 times 3 is 18. Divided by 2 is 9. Good. For a second there, I thought you thought that 6 times 3 was 9. I'm like, no, you're adding. Now I understand what you're doing. And then 8 times 3 is, divided by 2 is, okay, so I've got that. But 4 to the 3/2. Oh, man. What is that? Like, how do I even do that? Isn't that the same thing as the square root of 4 to the third? Right? I mean, that's how we write that. So we're taking 4 to the third, which is 64, and then we're square rooting it, which is 8. Or you could take the square root of 4, which is 2, and then cube it to get 8. So either way, you got 8. And some of you are like 4 to the 1.5 power. You're like, okay, no, I have no idea what I'm doing. All right. Letter I. What do you do there? Negative 2 to the fourth is 16. What do I do to the exponents? And I get x to the 4/3 over y to the second, z to the, there you go. Good point. The negative is being taken to the fourth power, so therefore it goes away. All right, now the last thing. We'll go through A, B, and C, and then you'll get your assignment. So we have the square root of a to the fourth, b to the seventh. Well, that's the square root of times the square root of. What's is a to the fourth a perfect square? Yeah, it is. Is b to the seventh a perfect square? No. Is b to the sixth? Yeah, b to the sixth is. So what do I put over here? So what's the square root of a to the fourth, b to the sixth? Yeah. Now I got cubed root. Is x to the fourth a perfect cube? Is x to the third? Sweet. So I got an x over here then. Is y to the eighth a perfect cube? Is y to the seventh? Is y to the sixth? Yes. And the key is if the exponent is divisible by the index, then it works out. Right? So the cubed root of x cubed is x. The cubed root of y to the sixth is y squared times the cubed root of xy squared. We don't circle our answers in high school. We box them. Circling, that's like for, I don't know, junior high. We box our answers. If you circle it, I'm marking it wrong. It's all wrong. Okay. Okay, last example. Um, I can't take a perfect square out of the W, so what should I do? Yeah, let's multiply them together. So square root of W to the sixth, V to the... Oh, are those perfect squares? So we have W to the third, V to the sixth. Sweet. Like it. Your assignment. It looks like it's very lengthy. It's not. It's odd problems, so there's like 32 divided by 2 would be about 16 there and about 5 there, so there's about 20 problems. I am working on putting your book pages and the answer keys uploaded online, but I'm running into some problems, so you're going to have to just be patient. I'm working hard. If you don't have your book with you and you'd like to borrow one from the stack there, go ahead. You have the rest of the hour to work. If you have questions on your entrance worksheet, so be it. Juniors, you leave at what time? 1:34, I believe it was. And so that's why I wanted to get through this quick. Seniors, you will stay here.